Dentin Formation by Harris Escobar. The process of dentin formation is called dentinogenesis, and this occurs by the process of induction and proliferation. The inner enamel epithelial cells trigger outer cells of the dental papilla. The outer cells of the dental papilla differentiate into odontoblasts, which are the cells that produce dentin. Stage or 12th week, apposition stage begins as the inner enamel epithelial cells differentiate and line up against the basement membrane. This causes or induces the outer cells of the dental papilla to differentiate as well. Inner enamel epithelial cells differentiate into pre-ameloblasts, and the outer cells of the dental papilla also begin to line up, repolarizing their nucleus further away from the basement membrane. In this illustration, we see the outer cells of the dental papilla begin their formation lining up against the basement membrane in mirror images of the preameloblast. Here we see the start of dentinogenesis, as the odontoblasts start to lay down pre-dentin. As this happens, the basement membrane will begin to disintegrate, and the preameloblast will further differentiate into ameloblasts, which will secrete the enamel matrix. The appositional growth of enamel matrix and predentin eventually dissolve the basement membrane, which will be known as the dentino-enamel junction. The process of enamel production begins after the production of predentin, therefore making the predentin thicker. As we know, the process of making new body parts is a very delicate one. Now we will visit some clinical considerations during dentinogenesis. Dentin dysplasia. This happens when there's an interference with the metabolic process of odontoblasts. This results in a faulty development of dentin and/or pulpal morphology. It can be rare, hereditary, but can also involve local factors such as teratogens, trauma, or infections, and several types can be observed. Dentinogenesis imperfecta, which has a hereditary basis resulting in brown, bluish gray, or rainbow opalescent teeth. The unsupported enamel eventually chips off, leaving the underlying less mineralized dentin showing. Here we have dentin dysplasia type 1, also known as radicular dentin dysplasia. Here we see clinically these teeth look fairly normal, with fairly normal shape, color, and size. The anterior teeth are missing, but why? Further in the radiograph, we see no root formation and no pulp, as well as several periapical radiolucencies. This causes the mobility of the anterior teeth and premature loss. This is dentin dysplasia type 2, also known as coronal dentin dysplasia. Here we have the reverse of dentin dysplasia type 1, where the coronal aspects of the teeth are affected. If we look at the radiographs, the roots look unaffected. These are the references I used, our very informative textbook for this class, also an article about oral and maxillofacial pathology. Thank you for your time.